Okay. Well, good morning, everybody. Welcome to our Argo Workflows contributor workshop. Thank you all for completing the survey, and thank you for all coming along today. I'm just going to start with an introduction at the moment, where I'm going to talk a little bit about what we're going to do, and then I'm going to hand over briefly to Simon to give some kind of overview information, and then it's going to get hands-on at that point, and I'm just going to touch on what you might want to do to get ready for that. Now, you'll get the most out of this workshop if you can do the hands-on stuff, and the format will be kind of typing code into your IDE and running tests from the command line. So I hope you guys are all comfortable with that. You'll get the most out of that, but we'll also talk about some other things you can do to contribute as well, which are very useful. Just a walkthrough of what the hands-on change will be, which I think you guys will be very excited about. We're going to start up Argo Workflows running locally, as you would for development. We're going to make a change to a thing called a proto file, which is the files used to generate the APIs, to add some new information to your workflow. We're going to write a unit test for that. We're going to run that in a debug mode. We're going to write an E2E test. We're going to show that in the user interface as well. We'll look at how to commit that code, create a PR, and to document your change as well. So the whole kit and caboodle of everything you need to do to make a feature change. There's a couple of things we won't be covering. Obviously, we won't be merging your PR. I'm sure you guys will want to merge it after you've done it, but we won't be doing that. And we probably just don't have enough time to go over MySQL and how to debug failing CI builds. So we'll probably skip over those. We may or may not do some user interface stuff, and that will kind of depend on the time. Most people don't submit UI-based changes to PRs, even though that's super easy to do. So that's why we're not going to be looking at that. There are some prerequisites for this class, so it's great if you can. Obviously, most of you already signed up to the sign-up form, so that's fine. There's a Slack room to join, and that's the kind of where we'll be pasting code snippets and where you can help one another out. And I'll be asking Simon and Bala to help with running that while I do a lot of the talking. There's a number of software prerequisites to install. These are things like Docker, Kubernetes, Golang to be able to make the file, and whatever IDE you're most comfortable with. We use a mixture of IntelliJ and Golang, and I'll be showing my changes in IntelliJ. But use whatever you're most likely to do. We'll be dropping out to the console at a number of points in this as well to show you how to use a console. So obviously that'll work in regardless of what IDE you do. If you've not written Go before, I can recommend, you won't have time now, there's a tour of Golang. It takes probably 2 to 3 hours, and you'll go from never writing a line of Go to being a competent Go programmer. Go is an incredibly easy language, one of the easiest languages I've ever had to write in, and you can learn it pretty quickly. There is an acid test, litmus test, acid test. I can't remember the right term. You can do to make sure all your tooling set up is that run make pre-commit, and that will run through all the tools. I do expect some people to have some issues with that because we use Proto C and some Swagger related stuff, and you may have different versions installed on your computer. That may cause problems, but we'll work around that, I think, as well, with providing a patch file for you. Okay. So a little bit about myself and about Simon and Bala. I'll let them introduce themselves when they come along. So I'm the principal engineer on Argo Workflows. I've been working for Intuit for about 3 years. Oh, it doesn't feel that long. Primarily on Argo products. So I also work on Argo CD as well. And so we predominantly work in kind of a smorgasbord of different languages. Before this, I came from the UK, working on QuickBooks over there. So that's who I am. Let me just go through this. So I think we've covered all the main items in the introduction. I think I'm going to hand over to Simon. Are you ready to do a little bit of an architectural overview?
Yes, sir.
Brilliant. I'll hand over to you, and you can take the screen share if you want to.
Awesome. Hi, everyone. I see a lot of familiar faces. So if I've already talked to you in the past, hello. And if I haven't, my name is Simon. I'm also an engineer at Intuit. I've been at Intuit since I graduated from college around 1.5 years ago. And I work on Argo, as most of you know. So what I'll be doing is I'll be showing you, giving you guys a main overview of the architecture and like the core concepts of how Argo works, so that you can get sort of like the high level overview of what segment of the code does what, and like if you want to make a change to this specific sort of routine, what should you do, and so on. So I'm going to share my screen. I think, yeah, perfect. I think Alex needs to stop sharing his. Cool. So can you guys see my screen?
Yes.
Yep. Cool. So I'm going to start with this little presentation I threw together this morning. I think the main concept that most people should be aware of when starting to develop in Argo, and certainly the concept that I thought was most important that I learned when I started, was that the source of truth of your workflows is always in Kubernetes. So some of you who may have had previous experience with Kubernetes might already know this, but I didn't in the past, so it was important for me to know this. Argo itself is just an operator. So essentially, Argo, you can think of the Argo controller as one big function. It has inputs and outputs, and that's pretty much it. Where your data is stored most of the time is on that same custom resource definition, which is a workflow CRD, and that lives on your Kubernetes cluster. So Argo, essentially, all it does is whenever it needs to, it loads that workflow from the cluster. It applies all its logic, which we now treat of as a black box for this example, and then it outputs a new updated workflow, and then it stores that updated workflow back in the cluster. Of course, it may also have some side effects, such as creating pods, deleting pods, and so on. But essentially, you can think of Argo as one big function that takes this input, a workflow, and outputs an updated workflow, and also some side effects. So to demonstrate this in a very simple way, here we have, you guys can have a workflow on your cluster, and then Argo is just sitting there doing nothing, idling by. And then suddenly an event happens, Kubernetes event. So an event may be any sort of thing that will trigger Argo to essentially operate on your workflow. And the two main events are you add a new workflow or delete a new workflow object to the cluster. So anytime there's a change with a workflow object anywhere in the cluster, Argo will get notified, and Argo will pick up the workflow itself. And the other relevant event that could happen is any sort of change or update to a pod that was started by Argo will also trigger an event. So for example, let's say your workflow is running and then your pods are running and then they're doing their thing. And then once they stop running, once they finished, Argo needs to know that so that Argo can continue its operation. So that could also be an event. So here we have an event. Kubernetes triggers an event. Argo's like, okay, this is an event to one of my workflows. I'm going to pick it up. So he makes a copy, literally a copy of the workflow in its memory, and it starts churning. So essentially, this is when all the implementation of Argo goes by. So Argo will look at at its current state. Argo will also look at the spec to see what else to do, and essentially it'll run all its logic. And then once it's done, it'll output a new workflow that is now updated. And as part of that, Argo will essentially load or store the updated workflow back to Kubernetes, and then that'll be it. So some things important to note with this sort of architecture that we have is that the workflow object is two things at once. It is your definition, which is the spec field. So anything you define, it's stored in the workflow, but it's also the state. So the state of the current workflow is always in the same workflow object. So this is, for example, why Argo, the controller can crash or the controller can be updated in the middle of an operation and really won't matter because the state is always stored in the workflow. Do you guys have any questions up to this point? Let me try to see if I can open the chat. So I guess I'll ask either Bala or Alex to read questions. One last important thing to note, which is very important to the design of how Argo works, is that since Argo doesn't keep any state itself, the only state that ever is stored is in the workflow itself. An operation has to be idempotent. Idempotent means that if, for example, Argo were to accidentally pick up the same workflow 3 times in a row, the result has to be, it won't actually change anything. Let me explain that in a better way. So let's say, for example, we go back in this presentation. Argo triggers an event. Argo picks up the workflow. He computes state 2 from state 1. So the idea is that if, for example, for whatever reason, Argo were to pick up state 1 again, it would compute state 2. And if Argo were to pick up state 2 again and nothing had changed to make it state 3, Argo would also compute state 2. So you can run the same workflow 50,000 times and it really won't matter, because as long as nothing external has changed, such as a new pod has finished, Argo will compute the same result. So that's another big thing that I learned when starting to develop in Argo, is that your ideas always have to sort of take into account the sort of idempotency that the controller must have, so that it works this way. And it'll get easier as you get your hands dirty with it. So having covered this, this is a sort of more concrete slide of what I just talked about. So here we have the Kubernetes server. So when I mentioned events, in Kubernetes, they are triggered through an informer. So an informer essentially is a pipeline or a function or a handler that sort of gives you those events to the controller so that the controller can act on them. And as I mentioned before, there's 2 main types of events that Argo cares about, a pod event and a workflow event. Taking in the easier case to understand the workflow event. So if a new workflow gets updated, a new workflow gets added or updated or whatever, it will come in through this informer. We'll add it to a workflow queue. So Argo maintains a queue of all the workflows it has to process. This queue is usually empty if you don't have that many workflows, but if you're running, let's say 50 workflows at a time, it might get a bit more full. And then you have a bunch of workers that actually do the operations on these workflows. So you process the item, you reconcile all the pods. Pod reconciling means that Argo will query Kubernetes to see what pods are running and what pods are not. And it'll make sure that all the pods that need to be running for the specific workflow are running, and pods that are not running shouldn't be running. And it'll do all the things that it needs to do. And then on the other side, if a pod update happens, we also have some logic to sort of pick which workflow this pod belongs to. And then once we know which workflow the pod belongs to, we add that workflow to our workflow queue so that it gets processed. Another sanity check, if for example, you were to add the same workflow 5 times in this queue, let's say 5 pods finish at once, it won't matter again, because again, the operation of a workflow is idempotent. So for each of those 5 times, the result will be the same as if it was only run 1 time. And then I will also like to cover the server, the Argo server, because it's a very important feature that a lot of you guys use. So the Argo server and the controller are 2 completely separate entities, and they never communicate with each other directly. So the controller, as I just spent like 10 minutes explaining, the controller is responsible for picking up workflow objects from the server, operating on them, and then storing them back in. So again, the source of truth for all of your state and logic is always the Kubernetes cluster. So the server sort of works with the same idea in mind, that the source of truth is Kubernetes. So when you communicate with the server, either in a hosted mode or in a local mode, the server only talks to those Kubernetes resources on the cluster. It never talks to the controller. So let's say you want to create a workflow with the server, then the CLI will talk to the server, and the server will create a workflow object in the Kubernetes cluster. And then as soon as that object is created, the pod informer will inform the controller. The workflow informer will inform the controller that a new workflow has created, and the controller will start operating on it. So those are the 2 main principles. To recap, to summarize, the 2 main principles are: state is stored in the cluster, and the controller is idempotent. Having covered all of that, I just sort of want to give you guys a quick little tour of repo, just to sort of get you guys acquainted to where you can find in the code everything I just talked about. So starting from the top, the command folder is all our CLI. So this is all our CLI code. You can see here that we have all of the commands that you guys are probably used to: delete, get, resume, retry, submit, and so on. We also have our cron and template and cluster template commands in here. Docs, you guys, I'm sure you guys are also well acquainted with that. I wanted to highlight that we just added a new fields doc. Where is it? So this is an auto-generated doc that essentially, this is more of a tangent. This is an auto-generated doc that shows you all the fields that you can use in Argo. It makes it pretty accessible. So for example, let's say you want to know what this specific field in, like what metrics are, right? How can you define metrics? So here you have the metrics field. And the nice part is that there's these little drop-down menus that once you open them, they actually link you to all of the examples that contain this field. So this is for PodGC, this is for metrics, and then you can click through this. So I wanted to highlight this because it's new and I'm pretty sure that this could be useful. So going back, examples I'm sure you guys already know about. And then let's dive in here first. So this is probably the most important sort of package that we have. It's called workflow, and this is essentially all the code for the workflow controller. So all of the workflow controller lives here. I guess it would be nice to just show you guys sort of like an example of something we talked about. So this is the operator. So this is where all the complex logic of the workflow lives. And then this is the main function, the main idempotent function that sort of runs all your workflows. If you guys want to take a look at it. It'll definitely take more work to understand than the time I have to explain it. And then here we have all our server code. Again, the server is completely separate from the controller. And then you guys can find this stuff here. And then something that you guys will most certainly have to deal with when contributing is the makefile. You obviously can find our makefile here, and I'm sure Alex will talk about this more in the coming minutes. So I think I see some questions in the chat. I'm gonna try to open those and see if I can answer them. Yes, the word is idempotent. And I'll just leave it open, I think, for a minute or so, if anyone wants to ask any questions about everything I've just explained. Or asking for clarifications is also okay. Oh, great question. How do different executors fit into the architecture? Yes. So that is actually a great question. And then, so an executor, let me try to find the best way to explain this.
Simon,
okay, so when
the executor in the workflow.
This is quite a specific question about a specific piece of code. Maybe you take this up in the chat room.
Yes, so I'll just give a quick overview about the what an executor is, and then we can discuss specifics later. So when Argo creates a pod with your containers on it so that they run, Argo also adds a little sidecar container to it so that it can read its output and it can store its artifacts and it can also insert its artifacts. And we call that an executor. Now, there are many interfaces or APIs that it can do that on. It can use kubectl, it can use process namespace sharing, and so on. So those are the different executors that we have. And those executors, depending on your use case, one might be better than the other. And also as a quick overview, there's an overview of the different executors under the docs. And then I think it's called workflow executors here. So any other big picture general questions or clarifications? They are not isolated from their sidecar containers. They are part of the sidecar containers.
And mainly that executor's job is like maintaining your input artifact and output artifact. Like any container will be responsible to download your input artifact to store it for your main container. Then the wait container is mainly like monitoring the main container to get complete. Then get that all the logs and the output of the container and push it to that artifact or parameters.
All right. So I think thanks, Bala, for that. And I think now I will hand it back to Alex. If you guys have any questions during this workshop, feel free to send a message to the Slack channel, the Argo Workflow, I think it's called Argo Workflow
Yes.
workshop Slack channel, and I'll be happy to answer them. And you can also send me a message on Slack at Simon anytime. Cool, thank you very much.
Great stuff, thank you, Simon. I'm just gonna share my screen here as well. Let me get this right, desktop one. There we go. Okay, I don't know why he's moved that one over there, but we'll move it out of the way. So this is going to be the hands-on part of the workshop. So you should probably have the code checked out by now, and you should have an IDE ready, and I'll just talk a little bit about that. So this is my terminal. When you write Golang, code goes into a specific path inside your home directory. So it goes in go/source/ then the name of the repository. It can't go anywhere else. That's the Go rules. Because Go then downloads and compiles things against that. So the first thing to do is just look at a couple of, there's two kind of key files in this repository. One is the make file, or where is the make file gone? It's in no particular order. Well, there's a make file. I can't see it, otherwise I'd highlight it. Oh, there it is. That is used to build the code. And then there's a Docker file that's used to build the Docker containers. And we have a special Docker file.dev to run. So the first command to run is just make start. And that will attempt to build yourself a Kubernetes cluster. So at this point, you should have already had a Kubernetes cluster available, and just run make run. I'm going to ask people to give me a thumbs up in the chat room, so in the Slack room. So if you're successful with this, then that would be really good to know. Just because I want to know how to pace this workshop. So if you're able to do this successfully, that I'd like to know about that. And if you're having some issues, let us know in the Slack room as well. While you're doing that, I'm just going to tell you what this actually does. So the first thing it does is going to print out some information about your checked out code. That's so you can just check what status you're in. Then it's going to create a namespace for your Argo to live in. That's called, sorry, I'm just going to put that over there. That'll create a namespace for your Argo to live in. It's just called Argo by default. And then it'll install various bits of useful software in there as well. So it'll create some service counts and some roles. One thing it'll do is it installs Postgres by default. So you've got a database so you can test archiving, and it installs Minio. And Minio is basically a way to edit and save artifacts. It's basically API compatible with S3, so you can use it in place of S3 for development. Then what this does is it scales down your Argo server and workflows controller. So by default, we'll it deploys the latest version. But whenever you deploy latest, it pulls that down from Docker Hub. And we don't actually want to do that. So what we do is we scale those replicas down, and then we basically wait for them to go away. After this, you can't actually see it here, but it'll actually build some images of the things. What I'll do is I'm going to run this with make clean, because I think I'll probably show it a bit more clearly. And actually it'll show some more details as well. Okay, so it'll running make clean has actually caused it to build the image. So there are three images involved in Argo workflows. One is called Argo exec, which is the executor, and it's the job of the executor to get your artifacts in and out and monitor your individual workflows. There's the workflow controller, whose job it is to actually run the workflow controller. And as of version 2.5, there is a piece of software called the Argo server. And it's the Argo server's job to provide an API server to serve the user interface and to provide, I think that's it. I can't think of anything else it does. Part of the Argo server is the user interface, and the user interface is built using Yarn, and we use Yarn build and a piece of software called Webpack. And Webpack takes a React application written in JavaScript or TypeScript and converts it into a single web page application with a single JavaScript file. So it kind of compiles the whole thing together in a static file. And then we just go through and build various containers. So you can see that it's going through and doing that now. You can also see a couple of kind of light blue info lines. These are special lines around K3D where it imports the images into K3D. So if you're using K3D, you'll see that. If you are using Docker for desktop or Minikube, you won't see that. I don't know about Minikube. I think Docker for desktop, you should be fine. I don't think you'll need to import the images. One of the other things it builds during the build process is an image called cowsay. Cowsay is very similar to the whalesay image. The problem with the whalesay image is that Docker Hub is not always available. So using whalesay tends to make things a little bit unreliable. When that's finished, I can run. You can run make port forward. Is everybody okay with this process so far? Thumbs up. Cool, great. Thank you for your thumbs up. Make port forward just runs a series of Kubernetes port forward commands, and we can now open up local port 2746 and Argo Workflows. Now, the version you get for development is based on the quick start guides, and the quick start guides are intended to demonstrate a number of different features of Argo Workflows, including things like authentication and authorization. The way to get a token is to just run Argo, make the CLI. That'll make you a new CLI that'll be in a dist directory. And if you go /dist/Argo auth token, that will give you an auth token. Now you should be able to run just an Argo auth token if you've installed that from Brew, for example, and you can copy and paste that into Vox, login, and you should be able to see the standard interface here with the various different sections on it. And it's just worthwhile just checking it works by running, just submit a new workflow, and you should see the workflow running in your Kubernetes cluster. Okay. Okay, so that's relatively straightforward. That'll give you a running system to try and play out with locally. But what we haven't actually done is make any kind of code changes today. So we're going to look to make a relatively small code change that covers a number of areas of the bit of the code. And what we're going to do is we're going to make a project called Emoticon. An emoticon is going to add an emoticon to the workflow based on what happens on completion of the workflow. And you can decide what the rules are for what kind of emoticon it wants. I'm going to decide if the workflow has the word Argo in the name, but you can choose whatever rules you want to do. So the first thing to do is obviously check out a branch. Is that the right spelling of emoticon? I will use that one. And then it's just worthwhile just running make start port forward, and it'll build up some new containers for you. And those containers will get a new tag. The tag will be emoticon rather than latest. So it's just kind of useful to do that. Everything that forms part of the workflow specification is in the package directory. And if you go into package APIs workflows v1 alpha 1, and I'm going to ask Simon, do you think you could post a link to this so people can find this for themselves when I move out the window?
On GitHub?
On the Slack channel, just
yes.
So when I
I'd be happy to.
And I'll copy some of these code snippets in there as well, kind of things you want to ask. So what we're going to do is we want to add something similar to the node phase called emoticon, and we're going to choose a couple of names of emoticons. And what we're going to do is create a new type called emoticon. That's just going to be a string. Okay, that's very similar to node phase. And what we can do is we can create a couple of useful constants. And none of this stuff is unusual. And we'll have emoticon happy. That's going to be smiley face. Then we'll have an emoticon sad. And that's going to be a happy face. There we go. You can choose whatever emoticons that you want. I'm just going to pop this into the Slack chat room for you there. Okay, so that's emoticon happy and emoticon sad. Now what I want to do is make those guys available as part of the status of the workflow. So the way that I would do that is I would add it to workflow status. And workflow status is represented by this type workflow status. If I click on that, I can see all the various different fields that that has. I'm just going to add a new field called emoticon with a type of emoticon. So I've got my new field there. Now, this workflow types and cron workflow types and workflow types are used to generate proto files, which are used to generate the APIs. And the way that we update those is by going to the console and running a command called make code gen. And make code gen runs the various code generation files. Now, this is probably going to be one of the hardest parts of the workshop, specifically because the make code gen task uses a number of different dependencies on it, of it. So what we'll do is I'm going to run it. I'm then going to get the git diffs and I'm going to pop them into a file and I'll share that onto the contributor workshop so you can use that if you want to. But if you're successful, well, that's really good news as well. So the first thing it does is it generates a generated proto file, and you can see that it's going to get a bunch of Go dependencies to achieve that. And this can take a couple of minutes. So I'm going to have to, you know, the enemy of every radio DJ is dead air time. You know, it's very important not to have any kind of like pauses because it, you know, really interrupts the flow of any session. I'll demonstrate now what a pause is like. It's horrible, isn't it? A bit of dead air like that. Okay, so Daniel, good chime. Error image never pull. That is intentional. One of the aspects of the make start is it sets image error pull in it. What I would suggest to you is check out a branch of the code and run make start again. Make start will force it to create new images. If that doesn't run, make clean start. Hopefully this won't take too long. Now, while this is baking away, let's move on and let's write a test for our emoticon. I can do in IntelliJ, the name of the test file is typically named after the name of the Go file. So I know it's this workflows test.go. I'll paste this file in here for the unit test. I'll just get a new function, doesn't really matter where this file is, func tests emoticon, and then we'll just copy the method signature from a previous function here. And then I'm just going to write a test for this. I'm just going to test, I want to create a new emoticon based on some kind of conditions around my workflow. So to do that, I'm going to create a new emoticon command. I'm going to give it a workflow as the parameter. I'm going to emit an emoticon at the end of it. So this is my command, and just for my default implementation, I'm going to emit emoticon happy, and then I'm going to write a test here for that. Well, let me just share that block of code for you. There we go. And I'm just going to run new emoticon. I'm going to give it a workflow as a parameter. And I'm going to, I think my rules for this is if the name of the workflow, is it name? And then we'll have a name. I can type the word name correctly. It's Argo, it's going to be happy, and if the name is something else, other, then it's going to be an emoticon sad. Okay, so this is my test. I'm just going to pop that there, and you can copy that, and then I'll show you how to run the test. I'm hoping the code gen is completed. Well, I'm going to come back to the code gen and show you what it's created shortly. The way to want to test in Go is to run go test and then give it the name of the package. In case it's pkg API. Well, for a second, pkg API. Now, what this command will do is it'll run all tests. I just want to run test emoticon. So run go test run test emoticon will cause this test to run. Oh, it says no to that because have I misspelt it? Oh, I have emoticon. That's now making me think I've misspelt emoticon all over the place. There we go. So my my test has completely failed there. That's what I want. That's what I expected because I wanted to write the test before I write the code. So there are two things that have gone wrong there. New emoticon has returned the wrong values there. So I know there's a couple of bugs in here. The first one is I haven't created this as an emoticon. That actually needs to be an emoticon there. And I haven't implemented the rules for the test. So that's the first bug I'm going to fix in my code. And if I run that test again, we should see that the first test now passes and the second test fails. So I can see that the second test, I expected an unhappy face and I actually got a happy face. And that's because my implementation doesn't take any interest in this workflow here. So what I'm going to do is add a little condition. Workflow name contains Argo, and then I'm going to return emoticon happy. Otherwise, return emoticon sad. Ooh, it's because that needs to say emoticon as well. There we go. So my test is passed. So what I'm going to do now is I'll just share the working code. So you guys don't have to run too much of that working code. That's the working new emoticon command. And this is the test emoticon, so you can add that to your code base. Okay, so I said we come back to the code generation and we talk a bit about what code was generated. So let's have a little look at that. You'll see that most of the code changes I made here are in the pkg directory here. So let's have a little look at what's changed in here and let's see what's expected and what's unexpected. So a couple of Swagger files have changed and a couple of generated files have changed. These 4 files are all generated from the workflow types. And we can see if I open up this workflow.swagger, I've got a new field called emoticon here, which is a string. I can also look at the other generated Swagger spec. So this is the finally generated one. I can see that change has appeared there as well. So that's all good. I can also see the docs change has appeared here. And there's a new field in the fields docs called emoticon. Hasn't been given a description, so I should probably fix that. But we'll come back to that later on because you'll be sure that's picked up on the workflow in the test. Okay, great. So I've now got my emoticon in my code base. I can create it, but at no point am I actually setting it. So what I want to do is set this on workflow completion. So I'm going to pause there for 1 second. Anybody got any questions? Okay. So as Simon discussed earlier on, most of the logic around execution of the workflows can be found in the workflow/controller directory of the repository. And the particular files here of interest are controller.go, which is the main controller loop, and operator.go. On operator.go, basically, it will receive any information about changes in state of the workflow and try and understand what's going on there. So that'll be the file I need to make my change in it. I'm actually not totally sure where this happens, but I do happen to know that there are other things that also happen on workflow completion. So let's have a little look and see if I can find a bit of code for that. That's pod completion. Maybe it's just the word complete I need to be looking for. this is node completion. That's not the one I want. This is also node completion. Loads of places it could be in the code base. This looks very promising. What have we got here? Okay, so I happen to know that when we finish a workflow, we add this label called completed to it. And that is it's the word workflow full name / completed. So you may have seen this in the code base. So I know that I can see a number of things here happening on workflow completion. So I'm going to interject my new bit of code here. walk.workflow.status.emoticon equals new emoticon walk.workflow. Okay, I think that's probably going to do what I expect it to do. So when the workflow runs to completion, it should successfully add the emoticon to the workflow. I'm just going to add this bit of code here, so you guys know where to find it. And I've added this at line operator.go, line 1577. That's the line of code to add there. Now, this is a bit of a difficult bit of code to test. So what we're going to do is, there's a number of dependencies on different bits of other stuff. It's quite hard to test. So what I think I'm actually going to do is I'm instead going to run make start port forward and get a new version of my code running. This will take a few moments. So, let us know if you have any issues or any questions. I'm going to take silence as nobody's having any kind of problems at all.
Just a question from earlier. Do I need to manually create the directory structure under home, go, source, and then git clone into it? So I've just been git cloning to like home.
It's so long ago I did this, I don't know the answer to it.
I think if you actually get Argo by using go get and then the Argo repo URL, Go will do that for you. So they will not only download everything with Git, but they will also create the structure for you.
Okay, perfect, thanks.
Simon, do you need to run that when you're in your home directory?
I'm pretty sure there's a flag that you can set because that will interact with Go modules in a way I don't fully understand. But I think I think it would be best if you didn't run it on a directory where there's already a Go project.
So this took quite a while to compile. I'll tell you why it took a bit of time to compile. That this directory v1 alpha 1 is probably the deepest directory in the code base, and any change to that directory typically ends up propagating out across all the files. And so I can see that it's now run successfully, and I should be able to go into here and just start myself up a new workflow. I'm hoping, I'm not sure if I can see this in the user interface. I may need to go out to the console to check this. So he ran successfully. I'm hoping here in the YAML, it's appeared. So it has appeared. Can you guys see this at the bottom of the screen? You'll notice there's an issue there. It's a capital E emoticon, but it's added the emoticon, and he's got a little unhappy face there because he didn't like that I named it Awesome Bear, doesn't like bears. So let's submit a new one, and I'm going to give it Awesome Argo instead, and hopefully we'll see that because the logic I've chosen in my workflow to add the emoticon to it appears correctly. So have a little look, and then we can see the YAML down there. Oh, here's the sad face. I think I've got a weird Unicode character in my character set. So that's kind of what I'm expecting that not to be a happy face. I'm not super impressed. It's some strange Unicode characters, but we will live with that. Maybe I've used a strange. Maybe I've used a strange file. Is it just me getting a strange face? Is that a strange smiley face? Happy, happy, happy. So happy it's crying, crying with laughter. Yeah, various different types of unhappy face. Worried, confused. Ah, there's too many, aren't there? I'm completely overloaded with it. We will ignore that for the moment. I'm not going to fix that for the moment because I think it will detract from what we're trying to do. Okay, so this is the operator. We can tell the operator is a complicated file because it contains 2,600 lines of code, and we can also write a test here for the operator. This is, there are loads of existing tests in here as well I could probably piggyback on. I think I'm going to look for one that looks for the phase of the workflow in here, and I'm just going to try and piggyback on that to create a test that shows the workflow being successful, which doesn't appear to be a single test. Has that succeeded? Well, you know, we'll write a new test. Let's do that because I think they're relatively easy to do. I'm just going to copy a few bits of kind of standard code from somebody else's tests. This actually doesn't really matter for our purposes. This is just some very standard bits of code here as well. And I think we probably have a better example than that to use. So let's have a little look. I can't find it. I just want a really basic one. Hello world workflow. That sounds like a very basic one. And the wrong test. So this is a different type of test. This test is I would call this component level test. And this is typically, component level test typically tests several different bits of code. I think we want this status.phase to be, I forget what the parameters go in, expected. Okay, so I've got a new test here. So again, I can run that test from the command line. I need to give it the package name, which is workflow controller, I think. I should just run that single test there. So a little tip around testing here. It's quite hard to write these component level tests. If you're familiar with the test pyramid, the easiest tests to write are unit tests, and the hardest tests to write are end-to-end tests. And for Argo workflows, you can typically write one of those. You can typically write those three. But if you want to make your test cheap, then that's the way to do it. And maybe you need to operate on this twice to get it to run. I'm just going to run it in my IDE this time. I wanted to show you guys how to run it from your command line. Does he not run to success? Oh, he runs to error. I must be missing something. Let's just have a little look to see what somebody else does. Well, so my goal was just to show you how to write a test here. So I'm just going to share that test there with you. Then I'm going to share the command with you to run. So we're going to talk a little bit about how to run the control in your IDE, and Bala, I think you're going to take over from me to do that bit. Before we start there, I'm just going to show you how to fix that error. So you remember when I updated the workflow types, I added the emoticon field to workflow status. And you can see here that I actually, if you remember, you may spot that this bit I added myself, and this bit was automatically added. But what's happened here is that this has is incomplete. It's missing a block of JSON. So we can fix that by adding this bit of JSON here, just copying it from Bitfunds and then just giving it an appropriate name. Because typically we don't start with uppercase for that. And you can run make cogen to reproduce that. Okay, Bala, do you want to take over?
Yes.
Okay.
Hi, everybody. My name is Bala. Most of people know that. Otherwise, hi. I'm a staff engineer in Intuit, and I'm working on the Argo workflow past 1.5 years. And since last year, I am the only man in that Intuit side. But now we have like Alex, Simon, and Derek, almost 4 people we are contributing on the workflow side. So let me share my screen. Okay. I already did a make start so that my controller and Argo server is already running on my Kubernetes. I'm using a K3D get pods. So you can see that my controller and this one is already running. So I have I'm using a Golang IntelliJ version of Go. So let me do that. Now I want to debug my server code.
Bala, are you showing your screen?
Oh, sorry. Are you guys able to see my screen? No. Are you guys able to see my screen? Thumbs up.
Yep.
Okay, yep. Perfect. So I did a make start. So my latest the images are already deployed on my K3D, which is running. Now I want to debug my changes. So for that one, we need to stop the container running on the K3D or your Kubernetes. So that I'm doing a make down, which will do that. It will update the replica set to 0, so that that pods will be terminate. So the pods are terminating. Now I'm going to start the server. Server main function is in the command Argo main, which is here, and you can pass the server as a keyword and which namespace you want to run your server. Let's start the debug mode. And I want to keep the breakpoint on my list workflow. Okay. Before that, I missed to run my port forward so that my Postgres and everything will be port forward to the local host. Let's start. So the Argo server is started in the debug mode. Let's make a Argo list. Here, which is going server localhost :2746. So you can see that it has hit the breakpoint. Now you can do that all the debugging things. Like you can go to steps and step in and everything. You can do that, and you can monitor your values. Like what is your request you got, what are the parameters it's there, and everything. You can start debugging that for the Argo server side. So once you're done, we can get back to the result. So this is the way you can debug on Argo server. Let's go to the controller side. The controller is another one. Let me stop this one. So I have a controller. The controller main function is in the command workflow controller. This is the main one. When you configure it, you need to pass few element, which is like executor image, which you need to say what image of executor you need to test it. Because currently I'm in the main master branch, so that I have a lattice. Suppose if you have one branch, then our make start will create you the branch specific tag for you. Then which namespace you want to run. Let's start debug. So I have a breakpoint in the operate function. The operator.go, I have a breakpoint on the operator function, which is the entry point for all the workflows. So the debug mode is started. Let's submit a workflow.
Bala, when you have a moment, could you paste the configuration that you added to IntelliJ to chat?
Yes.
I've got one I can paste myself, but I think we probably need yours.
Yeah, definitely I will do that. Give me a second. So I submitted a workflow. Immediately the informer is informed to the controller. Controller is already picked that workflow and trigger that operate function. So now you can debug everything. So from here, actually, you can see that this is the context. Here you can see what is the workflow you submitted, which is a hello world. And so basically it has a generator name and all the things. Then you can keep debugging, like, what are the different steps are changing, what are the different functions, and you can check whether your function is properly updating that workflow object. Then it will save it into the Kubernetes. Let's go with that. Then, because every pod update, the workflow will get into that operate function, as the Simon mentioned that the item potent. So now that workflow is done, you can see here, which is sexy. Yes, the third one, like, debugging a UI. That one, you can do that with the UI folder. You can do that on start. Which will start with the local host, your UI. And basically, what are the UI change you are doing there, it will immediately get into here. I think I don't have these two things, that's why it's failing. Yeah, that's all from me. And most of the UI debug, we used to do it with the Chrome plugin. Mostly, because the code is a React code, so we used to do the Chrome plugin to debug that all the debugging stuff.
Thanks, Bala.
That's all. Let me put my configurations in the chat room.
Thank you, Bala.
Thank you, Alex.
I'm going to share my screen if I can figure out this. Okay, so that's given me an opportunity to tidy a few things up in my code base here. What I've done is I've committed that code. If you do a git fetch and a git check out emoticon, you can get the code. So if you have any kind of issues, that should get you up to speed. And there's a bit of homework to do to figure out how to fix this test here as well. And I've also on that branch corrected the spelling of the JSON. So now it's lowercase JSON. If you do this, if you update this line, then you can, at that point, that will regenerate the JSON files with slight changes. I'm trying to open the chat up here because somebody said a question, but it doesn't appear to be opening up. Oh, it's hidden behind the people talking. So Bala talked a bit about running this in IDE. I'm just going to show you where you can find out a bit more information. So if you want to understand what we run, the actual manifest that we run can be found under dist, and there's a dist Postgres YAML, and you can open up, and that's the actual YAML we run in the cluster. So if you want to find out what the Argo server runs, we'll just have a look for the Argo server deployments, which is almost just here. Here's the service. Here we go. Here's the deployment. And you can see that these are the arguments that it's used to run locally. So we run it with namespace mode. So the E2E creation is namespace mode. Client mode is client, so we can test client mode. And then we enable log level as debug. There's a couple of other ones we do here as well. So this upper iodb_debug causes our DB library to print out the SQL statements that it executes. So that's really useful for looking at SQL issues. This log level debug actually works for any CLI commands. So if I do Argo log level bug list, then it potentially shows some additional logging. I think quite a good one is probably. I want to show you. I think it's logs. It says logs. But if I switch this out of Argo server mode, then we'll see a whole bunch of additional debug information printed to the console there. So that's another option to get more debugging information. Unfortunately, if there's not a log statement to print the debugging information you need, then you'll need to use the YAML. Okay, so I wanted to talk a bit about E2E testing. So at this point, make sure you've got the latest version of the code and you've run make start port forward, and I'll show you how to write an E2E test. So the way an E2E test works is it tests by connecting to the actual APIs itself. And so what I want to do is run an E2E test, and all the E2E tests can be found under test/E2E. There are a number of different ones here. I'll quickly go over the purposes of them. So the Argo server test, its job is to check the API's appropriate response. CLI test and CLI with server test are there to test whether or not the CLI works correctly. And then there's a functional test and a smoke test to make sure that those things smoke. Now, I don't think we would normally recommend you actually write an E2E test for this. But what we can do is actually demonstrate how you might write and run one if you wanted to do this. I'm going to pick the most basic test here. This is test basic workflow. And again, I can run that from the command line by going in a terminal, go test, go test, minus run, name of the test, and then test stroke E2E. And that will run the basic workflow test. It just takes a moment or two to compile. So give this a go. I'll just drop this into the, it says no tests to run. Oh, maybe it's, I think I need to give the full name. It's that. It's a little more. There we go. So he ran the test, and he didn't print any debugging information for me. I wanted to see the rest. So what I can do is I can do make tests minus v. V. And minus v puts testing into verbose mode, and now he'll print out a lot of additional debugging information, which is what I wanted. Let me share that with you in the channel. Try again. Okay. And it actually creates a file here of even more detailed debugging information. So if I open that file up, it'll open it up here. And actually you can see there's a load more additional debugging information here around the E2E tests as well. So if you're trying to debug an E2E test, this will show you here. I can even see my emoticon has appeared in the information here as well. So the E2E tests, typically the really standard format of an E2E test does, You give it a file, in this case basic.yaml. If I have a look at testdata/basic.yaml, I can see it's just a very simple, oh no, hang on. Did I say test data? I don't know, I said smoke, didn't I? Sorry. It's confused because there are two files with the same name. I can give it a file that's a bit of YAML. I see that I'm running cow say, and it says hello Argo, and it says if not present. It's a requirement for all tests to have this Argo E2E label to be true. That allows us to clean up those tests and delete only workflows related to the test rather than other workflows you might be doing. So then we have a when section, which says when you submit this workflow and you wait for 20 seconds. So typically around 20 seconds is a good time to wait. If your test is taking a minute or 2 minutes to run, then we are not going to want to run that, because we only have 10 minutes to run all the tests in total. And obviously we can't run, we can't run, if we have tests taking 1 or 2 minutes, but then we only run like, 1, 5 or 10 tests, and that's not a very good test suite. So we have that. And then you just can have an assertion. So you can say expect workflow. And what I'm going to do is I'm going to say expect equal, and then it's going to be sad face. This may not work because it's a bit funny about this sad face. I think it's like it's the wrong kind of sad face. What we can do expect. Status.emoticon. Okay, let's run that test. I'll do a bit of compiling. I see my test running in the console, and there we go. It's all run successfully with my new condition. Okay. Check in my change. You guys can now get that change there. Now, a really important thing to do is when you're adding a new feature or functionality is document it. A document is a really good way for new users to find out of it and for you to communicate information about that. And we have a directory here called docs. And so what we can do is create a new file in here. I typically just take an existing file and I make a copy of it. And I just delete the bits I don't want from this file. So this one's the Argo server file, so I'm just going to delete all this stuff. I'm just going to keep this, and I'm going to state that this feature is an alpha feature. In the file, he gets an alpha icon, just to indicate it's a very new feature and we haven't really tried and tested properly. And the current version we're working on is actually either 2.8 or 2.9. So I'm just going to say this feature is available at 2.9. This means that people don't go, oh, it doesn't work. And you go, oh, what version are you using? Oh, version 2.7. Well, it's only available in 2.9. Well, why don't the docs say that? Oh, we can grant that too. Just really good to add these both here. I'm just add some text here. So I just add that to my thing, and I can just add that file into Git. Okay. That's my thing. Now you guys can find that bit of documentation. It's up to you what you want to write for your docs, for that's now on that branch. Now, before you create a pull request, it's usually a really good idea to check a couple of things. The first one is to make sure that the code doesn't have any kind of syntax errors. And you can do that by running make lint. And that will run a series of kind of linting tasks on your code. It will tidy up the Go modules. It will run a piece of software called Go Meta Linter, which does things like Go format, Go imports, and various other kind of checks for code issues and code bugs. That's the first thing to do. I'm hoping we're not going to find it. Now, what this will do is it'll automatically fix any errors that it finds in our code. The other thing is to run all the test suites. It's typically quite a good idea to run make test before you push your changes out to the CI server. And if you run make test, that'll run all the tests apart from those it finds in the E2E directory. And it'll print out the results for you as it goes along. So we just share those and you can run them yourselves. test. There we go. Implement and make test. Does anybody have any questions about writing tests or writing E2E tests, or anything they would like to ask about while you're running your tests?
Are there any sorts of changes that can pretty much only be covered by E2E tests, or is it pretty much possible to cover everything at a lower level?
So as I mentioned, there's kind of 3 levels of tests, and then they're generally suited to different things. There are definitely some cases that are quite, I mean, the goal of the E2A test isn't really to test everything. It's to test things that can only be tested in E2E tests, and that is things like APIs. So we typically test the API returns values, but not necessarily the behavior of it. So they're about, does the CLI print some output, not does it actually run a workflow? That would be the wrong kind of thing to do. That's kind of better at the component level test. And you'll see that operator underscore test is quite a long file with many tests under different circumstances using PVCs as well. That's typically a better way to do it. And the reason I mentioned a unit test is if you've got some kind of logic in there, that's typically better tested as a unit test. And if you can kind of figure out how to, I mean, it's definitely a quite, there is some science and there is some art to writing good tests. And it is typically, you can write unit tests if you write your code in a way to be unit testable, if you do TDD. That's quite a long-winded answer to it. The short answer is yes, there are things that can only be tested with E2E tests. But it might not be the right thing. And I'm using this as an example of writing an emoticon test, but I probably wouldn't have written an E2E test for this. I would have probably written a component level test for it. Let's see, did I get any changes here? So here we go. There was something wrong with my code. This line here says fix issue. Let's see what it looks like. Oh, it said it fixed an issue, but there are no differences. It wanted to go import something. It said it fixed it, but I can't see any changes. So maybe it was not fixed. And the test you can see are running there as well. So it looks like this is pretty good to me. Now what I'm going to do now is I'm going to, and I think you guys might want to do this as well, is create a pull request. Before I do that, why did my tests fail? So looking for fail colon will help me find the failed test. Oh, it's this test. What we'll do is, for the moment, I'm just going to disable the operator test. That can be a bit of homework to fix this test. And the way I can disable a test is running t.skip now. I run make test, it should now pass all those tests. Now, one thing that's quite nice about Go testing is if it doesn't think your tests need running, it won't run them again. And you'll see this word cached in the output to indicate that it's actually not running again. Go is quite specific about where it thinks tests should be. It's quite opinionated. And what it says is your tests should live in the same directory as your file. If they don't live in the same directory as your file, then they're not testing your file. That's obviously not necessarily true. You might have code in one test that uses, tests the file that actually depends on another file, and it kind of tests it through that dependency. But Go says that's not the case, and therefore it doesn't include that in, it won't rerun that test for you because it doesn't think that's changed. And it also thinks that that file shouldn't count to test coverage. So you may think to yourself, I've written some great tests here, but my test coverage hasn't changed. It's because you need to write those tests in the same directory as the file that's changed. You can see that it's running here now. I would say I'm about 30% confident these tests will pass. That's what I think. That's my confidence level. Okay, I'm going to assume it's going to pass. push that change. Then what we're going to do is I'm going to create a pull request for this. And you're welcome to give this a go yourself. We can create it, but we probably won't merge it. Now, you won't be able to push to our branch, but you will be able to create a fork of our branch and push to that. So I can create a pull request from the emoticon branch. And then what I will do is, now it's important to kind of think about how this pull request is set up. And the first thing to do is get a title. This is a new feature, so I add the word feat to the beginning of title, or if it's a fix. And I'm going to say add the workflow emoticon, and that helps me tick this second box. The PR is conventional, and helps me. I'm going to tick the first box as well, just because this is I consider this a chore. I assign the class, so I'm going to put an X in that box, and I've written some unit tests for my thing, so I'm going to put a tick in that box. And finally, I work for Intuit, and Intuit is in the things. And what I'm going to do is, rather than create a pull request that kind of tells people I want to review it, I'm going to create a draft pull request. And then what will happen is that draft pull request will be opened. It's going to recommend a few people here. So I'm going to ask Simon to review this. Simon's going to provide some changes to this, I suspect, but we'll come and have a look at those later on. And then it's going to run a series of jobs here in the CI. I'm just quickly going to go over what they are. And this code gen job, make sure that your generated code is appropriate. So it runs make code gen and then make manifests. These three E2E jobs run all the E2E tests in different configurations, including the MySQL configuration and no database. This test one runs testing and linting. And then the Docker build, make sure you can build a Docker build from the Docker build file, so make sure there's no problems with that. And then finally, the UI runs the UI, make sure that can be built and lints it. Okay, I'm going to quickly, Bart just touched on this, and I think we've got a bit of time, so I'm just going to spend 5 minutes talking about the user interface. So, the user interface is all in this one subdirectory UI, and the user interface basically is TypeScript plus React. React is a quite neat programming framework from Facebook. I'm sure they would love that I describe it as neat after all the hard work they put into it. And TypeScript is just essentially a heavily typed version of React. And we use the build tool uses a thing called Yarn, which again I believe is a Facebook build tool. And I just run yarn start to get the user interface to start up. The user interface, then the reason you'd want to do this is because running in this method has a hot reload feature, and we're going to use the hot reload feature to make it easy to make our changes. So he will, firstly, he will start up, and as he starts up, he will do a bit of compilation. He doesn't compile until the first time we run it. And now you can just see the very normal user interface here as well, okay? I can then go in this user interface and I can click around and see different things. What I've decided is my emoticon is so incredibly important, just an incredibly useful feature that everybody definitely will want to have the emoticon somewhere very, very key, very clear in the user interface. I think I might add it to this page here, I think. Okay, so how do I know where to add this to? Well, I'm not really sure. I'm just going to look for a couple of keywords. There's the word namespace in capital letters. So I'm just going to go in the code base. I'm just going to search for a namespace in capital letters. I genuinely don't know if you can. I'll find this. Now, I happen to know that all the TypeScript files have an extension of TS or TSX, and I can see that that's there. What I want to do is case sensitive. And this has brought me to this file here. Now, it might not have been case sensitive. There might have been some CSS. So lucky enough, I think I found where we put this information here in this file here, workflow list item. That kind of makes sense to me. I've got a line that contains the content and a line that contains the phase. So what I might do is I feel like this is probably the place to put it. I'm going to add props, .workflow, .status, .emoticon. And that's not going to compile in my IDE. I can see a red line there because that's my IDE is clever enough. And it's going to try and compile in the console here as well. So if you don't have a smart IDE, then the console will recompile that. And I can now see that some red printed the console. Emoticon does not exist on the type workflow status. Okay, let's go into workflow status, which is again I think workflows. And there's a number of files here that look very similar to the workflows types. They're just the version of it. I'm just going to add emoticon. I'm just going to say it's a string. I could create an enumeration here, but I'm feeling a bit lazy at this point. I'm going to see if Simon, my reviewer, will pick up and ask me to create a Newman. There we go. Now see compile successful. And now if I go to the user interface, there is quite a badly rendered emoticon in the background. Okay, so that just shows you, if I want to make a user interface, rather than kind of running make clean, make build to rebuild the Argo server, the easiest way to do it is to run yarn start. I get that emoticon in my code there as well. User interface change. So what I'm just going to do is I'm going to check that in. I push that change. It pushes to it. And it's always really good to see as a reviewer the change in the user interface. So what I'm going to do is I'm going to add a little screenshot of that. Let's attach that. How do I do that? I've got to drag it in. Okay, I have to go and look at what. There's nothing embarrassing on my desktop because sometimes there is. Oops. Put the screenshot on there. Preview that. There we go. We can see my kind of badly formed emoticon now appearing in the user interface. Okay, so this is my build. It's had a few moments to run. I've got a few green ticks, so it's looking pretty good. I'll probably come back in about 10 to 15 minutes to review that and see how it's doing. Okay, next I want to just talk about some of the other things, some of the areas that might be interesting to you if you want to get involved, get your hands dirty, how to find appropriate issues or where you might want to have a look at things that could be improved. But before I would do that, I just want to see if anybody has any questions they want to ask. And I'm just going to add that yarn command. People who want to run the user interface. Okay, any questions? Okay, I'm going to move on now. Argo is obviously open source software, and open source software really thrives on community contribution. I think we've been incredibly lucky recently to have typically around 20 to 30 people contributing to every release. And there's several different things you can contribute if you want to get involved. And first is, the most easy thing is, of course, just make some kind of documentation change. We get quite a few fixes to grammar or errors, or if you kind of work on a bit of area that you found really difficult and you think you could share your learnings, that's a really good area to submit a PR. And that doesn't really require any kind of code changes at all. As I mentioned, UI changes, if you've got some JavaScript skills, they're often a little bit easier to do than back-end changes. But as I mentioned, people are not that interested in doing user interface changes. I don't really know why. Another thing is maybe you've got a change that you would like to see or something that doesn't work in a way that you think, or a bug. So what you can do is you can raise an issue with that and provide some information about that. That's a great way to contribute. And better still is actually if you found a bug or a new feature, is actually contribute that yourself. Now, for a bug, if you're pretty sure it's a bug, I would just get stuck in. If it's a new feature, it's usually worthwhile having a bit of a chat to a couple of people about it beforehand, because sometimes it works that way for a reason. Sometimes there are alternatives to that feature, other ways to do that that we can provide. Or maybe we don't want, an example would be, would be, we would like Argo to check out code from GitHub. Well, we're agnostic to what Git provider you provide. We wouldn't want to add code to specifically GitHub, because then we'd have to add it specifically for GitLab as well. So we probably wouldn't want to do that piece of change. If you want to just pick up a random issue, we're very similar to other repositories that we use a couple of labels to indicate areas that we want help on. So one is help wanted. So you can have a look and see any kind of issues where we want some help on that, or diagnostics help. And the other one is if you're really more keen to just get into some code, then you can have a little look for a good first issue. And these issues are ones that have been cherry picked because we think that would be a great issue for somebody new to the code base to work on. Okie dokie. Now we're a bit ahead of time, which is really good news. I'm really glad that we're ahead of time. I would like to now just open this up. Does anybody have any questions or any areas they want to ask about, any kind of details they're interested in, or anything you found confusing you want us to go over again?
Hi, thanks so much. This was a really good walkthrough. I did have a quick question. You showed us how to debug the server and the controller and the UI. We've been kind of experimenting with the sidecar container more than anything, which is tricky to debug. Do you guys have a way of debugging that in an IDE or something similar?
So it's the sidecar container itself that's tricky to debug. Is that right?
Yeah, the Argo exec one.
Okay, so there is a new configuration option that Bala introduced recently. I think Bala's dropped off to deal with a production issue that prints the manifest of the pod on completion. So that can be quite a useful information. The containers typically have the ability to start with a debug mode. And in the configuration, I believe there's a field in config called executor, and that will allow you to run, choose what executor you run. You can choose to run a different version. You could build a new version that contains some additional debugging logic. I don't know if there's a debug flag we can add to that. Simon, you are an expert in this area.
Yeah, it's usually for me, the best way to debug in the exec container is just with print statements, unfortunately. It's just what I'm used to. So I will essentially just litter the area I'm interested in with print statements, run it. You can use kubectl -c container name -c/wait, and then you'll get the wait container pods, and then that's what I usually do.
Okay, thank you.
Okay, any more questions? What I'm going to do is I'm going to share with you guys some of the notes from the meeting. I'm going to add some homework if you want to do some homework. Add that to the end of this. And the homework will be to fix that broken test. Broken tests. And homework item number 2, your first PR. There we go, because that will be a great way to demonstrate what you've done today. If you've got any more questions, please feel free to drop a message into the Contributor Workshop channel. There's also an Argo Dev channel in the Slack, and that's really aimed at people doing contributors. So rather than contributor-related questions in the kind of Argo Workflows Slack, Argo Dev is going to give you a bit of a more, I was about to say refined audience. I mean, we are more refined, definitely. A more expert audience for your questions. Matthew, you have a question. I'm not showing any videos. The answer to your question. We will create a recording and I will put that onto YouTube so you can share that with people later on. Okay, great. We get to finish half an hour early, which is always wonderful. Okay, have a lovely day, everybody. Go and enjoy a coffee.
Thank you, everyone.
And we will hopefully hear more from you and see your pull requests soon.
Thank you.
Thanks.
All right.
Thank you.
Thank you very much. Cheers.